Welcome back to the Civil Engineering Masters. Today we are going to discuss regarding prescribed loadings. Okay, different type of loadings which are there in the structural dynamics. If you see here the definition of the prescribed loading. If the time variation of loading is fully known, even though it may be highly oscillatory or irregular in character, it will be referred to herein as a prescribed dynamic loading. Okay, the time we know the time is we know the time variations of the loading means time variation of each oscillation. Okay, that oscillation may be regular mean or irregular. Okay, when we take time period, that may be regular time period or it may be irregular time period. Those type of loadings we used to call as the prescribed loading. Okay, and the analysis of response of any specified structural system to a prescribed dynamic loading is defined as the deterministic analysis or prescribed loading. Okay, what they have seen, analysis of response of any specified structure. It may be bridge or it may be building or it may be any water tank, any type of structure. Okay, structural system to a prescribed dynamic loading is defined as the deterministic analysis. The type of analysis we used to call as the deterministic, whereas response indicates the three parameters like acceleration, velocity, and displacement of the structure. Okay, deflection or displacement parameters of the structure we can find by dynamic analysis or deterministic analysis we used to call. There are two categories of prescribed loadings are there. Okay, for analysis purpose, prescribed or deterministic loading divided into two basic categories. One is periodic loading, another one is non-periodic loading. Whereas periodic loading exhibits the same time variation successively for a large number of cycles. Okay, time variation will be same for each cycle, but there may be a difference in amplitudes. Okay, height of the cycle. Okay, those type of cycles we used to call as the periodic. Regular intervals will be there for each cycle, same time period, time variation will be there. Those type of loadings we used to call as the periodic. And this periodic will have two type of loadings. One is simple harmonic loading, the second one is complex loading. Okay, simple harmonic one loading and complex, both are having the regular successive time variations. Okay, time variation for each cycle will be same, but amplitude will be differs. Okay, that is the periodic. For non-periodic loadings may be either short duration impulsive loading, we can say short duration loads as impulsive, or long duration general forms of loading like long duration loads like earthquake loads. Okay, impulsive loads where when a boat a ship when ship hits to the pier of the bridge, that one we used to take as the impact load. And applying a bomb blast over the structure, that will be comes under the impulsive load. Okay, we will see what these are. Here for periodic loading we can see simple harmonic motion. First one is simple harmonic motion. The simplet periodic loading has the sinusoidal variations shown in figure A. Here you can see, we can see sinusoidal variation. Okay, the time taken for each cycle will be same for two successive amplitudes. The time the number of cycles completed in particular time period will be same. Okay, the simplest periodic loading has a sinusoidal variation shown in figure A, which is termed as simple harmonic motion. Okay, this type of motion where we can see those type of vibration when a machinery structure or any mission is subjected over a beam. Okay, when we switch on that machine will be release some vibration, and those vibrations will be plotted like this as a simple harmonic motion. Okay, loading of this type are characteristic of unbalanced mass effect in rotational machinery. Okay, if you take any rotational machinery, there we can see unbalanced mass. Sometimes vibrations will be in our forward direction, sometimes vibrations will be down uh, backward direction. Those will be released continuously. Those vibrations will be there continuously. That is nothing but simple harmonic motion. And second one is the complex loading. Okay, when we apply the hydrodynamic pressure, sorry, complex loading, hydrodynamic pressure generated by a propeller at the stern of a ship or by inertial effect in a reciprocating machinery frequently are more complex. When the vibrations comes in ships, okay, when it is moving, those type of vibrations we can see as the complex loading. Some hydrodynamic pressures, okay, the force due to the water, okay, water forces, those type of forces we used to take as the hydrodynamic pressure force, and those loadings we used to call as the complex loading. Here we can see time variation will be same in regular interval up to this point, same time period. The time period for next cycle also will be same. Okay, but there will be difference in the variation in their amplitudes. Okay, there we can see the amplitude variations, but regular interval will be there in each cycle. This type of loadings we used to call as the complex loadings. These two are the periodic loadings, whereas non-periodic loadings are nothing but impulsive loading. These are the short duration loading. Within seconds the destruction will be going to happen. Okay, these are the short duration effects. For suppose if you apply any blast or explosion is a typically source of impulsive loading for such short duration loads. Okay, for short duration loads we can take this blast or explosive type of loads are the short duration loads, or we can say impulsive loadings, whereas the long duration loads we can see as such as might results from an earthquake can be treated only by completely general dynamic analysis procedure. By using general dynamic procedure we can see the long duration loadings. Okay, when earthquake applied over the water tank, this tank is try to move towards the to and fro from its main position. Okay, and for this main position we used to draw a diagram like this, and this type of loadings we used to call as the long duration loading. These all are prescribed loadings in the structural dynamics.